Okay, so hello everyone, welcome. Can you hear me?
Yeah, hello.
Yes, I
Okay,
can
fine.
hear you.
Okay, thank you. Okay, just we are waiting 1 or 2 minutes for joining all of the other participant. Then we will start.
Okay.
Okay, and for getting the recorded video class, you have to just log in with your Gmail or email which you provide me. Just log in the YouTube, then you can easily access the recorded video class, which I already uploaded in the YouTube. Just you need to simply log in with your email in your YouTube, then you can easily access all of those recorded video class. Okay. Okay, so we will start now. So basically today is our second day's online training program, and first day I will try to discuss some basic things of Google Earth Engine platform, as well as also talk about some basic programming, such JavaScript programming. Okay, so talk about some function. Okay, so basically today I will try to discuss about some remote sensing application in Google Earth Engine platform, how we can easily implement the different types of web application, such as kindly mute that. Yeah, kindly mute. Yeah, I can get the echo. Kindly mute. Yeah. Okay. So for that, okay. So basically today I will try to discuss about some remote sensing application, such as how we can easily filtering the different types of satellite images, such as Landsat image, Sentinel image, Modis satellite images. Okay, and work with in Google Earth Engine platform. So let's go. Just I simply share my screen. Okay, so now can you see my screen? Yeah, is it visible?
Yes, visible.
Okay, thank you. Okay. Okay, so let's go our class. So basically today is our second day, and second day course continue with that. I try to discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat and Sentinel image, how we can easily filtering and displaying the satellite images, and after that how we can easily export the satellite images from Google Earth Engine platform, and then how we can easily use the different types of band combination. Okay, using the remote sensing, how we can easily use the different types of band combination, such as natural color band combination, false color band combination. So different types of band combination, how we can easily implement, we try to discuss about that, and how we can easily export the satellite images from the Google Earth Engine platform, how we can easily export the satellite imagery, and then how we can easily import, filter, reduce, clip, and display any satellite data from Google Earth Engine platform. For the import, filter, reduce, clip, and display data in Google Earth Engine platform. Then how we can easily make the time series chart for NDVI or any other indices, how we can easily make the time series chart. And how we can easily export any shape file from the Google Earth Engine platform, how we can easily export any types of shape file, we try to discuss about that. and calculating any indices from satellite images. Okay, any indices, it can be NDVI, it can be SAVI, it can be any other types of indices, how we can easily calculate using the satellite images in Google Earth Engine platform. Okay, so let's go. First of all, Earth Engine public data catalog. So Earth Engine is a totally cloud-based platform. When you're using the Earth Engine data catalog or Earth Engine platform, you don't need to download any types of satellite imagery. We can easily access all of those satellite images. It can be Landsat, Sentinel, MODIS, Crane, land cover dataset, atmospheric dataset, and this dataset is updating daily. Okay, so in Earth Engine public data catalog, we can easily find out more than 200 public dataset, more than 5 million images, more than 4,000 new images every single day it provides, and we can easily access 5 petabytes of data from the Earth Engine public data catalog. And this is the link about the Earth Engine public data catalog. You can easily simply go to this link and you can easily access the Earth Engine public data catalog. Or you can simply open your code editor. Simply open the code editor and then go to the top of the code editor. We can get a search bar where we can easily search our place and any data set. We can simply search in here. You can see search bar. So I browse data catalog. Click on here. So then I can easily access all of those data set. Okay, such as you can see, we can easily access the data set about that surface temperature data set, climate data set, then atmospheric data set, weather data set, different types of weather data set, as well as also imagery, Landsat, Sentinel, then MODIS, high resolution imagery, geophysical data sets such as terrain, different types of DEM data set, land cover data set. So all of those data set, you can see choroplane data set, other geophysical data set, all of those data set I can easily access from here. So mainly it's the Earth Engine data catalog. Okay, and when I click on here Landsat, here I can got all of those Landsat image collection. Okay, you can see. Okay, I think some person will join. So when I click on here, you can see here I can get all of those Landsat image collection, such as Landsat 9, Landsat 8, Landsat 7, okay, as well as Landsat 5, Landsat 4, and Landsat 1 to 5. So all of those satellite image collection for Landsat, I can easily access from here, okay. As well as also you can see when I click on the MODIS, then I can get all of those MODIS product, okay. There's a lot of MODIS product we can easily access from here. You can see MODIS BRDF adjusted reflectance daily 500 meter resolution, this data set. Also MODIS albedo daily 500 meter resolution data set. So all of those MODIS product we can easily access from here, okay. As well as also you can see other data set is about that MODIS albedo quality 500 meter resolution, this data set. So all of this MODIS data, you can see the MODIS land surface temperature data set for 1 kilometer resolution for daily. Okay, all of those data set I can easily access from here for the MODIS, as well as also Sentinel. Here I can got all of the Sentinel collection, such as Sentinel 1 or SAR data, Sentinel 2 multispectral instrument data. Okay, Sentinel 3, Sentinel 5. All of this data set I can easily access from the Sentinel. So now I talk about the Landsat imagery. Okay, how I can filter the Landsat image collection for my specific region. Okay, so let's go. I explain all of those things one by one. So I hope you can easily understand about that, how you can easily filtering the Landsat image collection. So filtering and visualizing the satellite images in Google Earth Engine platform. So mainly it depends on the 3 factor. Okay, 3 factor you need. First of all, you need to select your region. Okay. First of all, you need to select your region. Suppose I need this satellite image for the Dhaka city. Okay. So this Dhaka city is my region of interest. So this is my region. And another thing is that we need to filter image specific properties. image properties. Suppose I need only for this image, which image will be not more than 1% cloud cover. So this is another factor for filtering. I need only for this image, which image will be not more than 1% cloud cover. And another factor is that specific time period. Suppose I need the satellite image for year of 2017 for the rainy season or dry season or any specific time period. When you filter any types of satellite images, it can be Landsat, it can be Sentinel, just follow the three factors. One factor is that your specific region. Another factor is that specific image properties. I need only for this image, which image will be not more than 1% cloud cover. And also filter a specific time period. I need the image for the winter. I need the image for the summer. I need the image for year of 2017. Just filtering. So when we filter the image collection, we just follow the three factors. So let's go. We try to show the practical example how we can easily filtering. So first of all, suppose I want to work with the data set. Suppose Landsat 8. Okay. All of this filtering process is the same. I show you Landsat 8. You also try for own self for Landsat 9. Okay. So for Landsat 8, I click on here. Now I can get all of this information about the Landsat 8. Here you can see the mainly Landsat 8. We can get the three types of sensor: surface reflectance, top of atmospheric, raw image. Okay. So mainly surface reflectance, this satellite image we are using for making the land use land cover classification map. Okay. For the surface reflectance image, mainly we are using for the land use land cover classification map, as well as change detection of land use land cover. This type of work mainly we are using the surface reflectance. And top of atmospheric image collection we are using for different types of indices. Suppose you calculated the NDVI, NDWI or other type of indices, then top of atmospheric image collection works very well. Okay. And all of this image collection filtering process is the same. So in this time I show you that surface reflectance. Click on here. So now I can get all of this information about the Landsat 8 surface reflectance satellite image. First of all, data set availability. We can get the data from year of 2013, March 18, and 2023, August, 2nd August. Okay. So this is the time period. Between this time period, I can access all of the satellite images in Landsat 8 top of surface reflectance. And this dataset provider, you can see provider is that USGS. Okay. United States Geographical Survey. So USGS provide this data. And Earth Engine snippet. Earth Engine snippet mainly it's a unique ID. Okay. Every image collection has a unique ID. So in this time, you can see Earth Engine snippet. This is the unique ID for Landsat 8 top of surface reflectance satellite imagery. So this is the unique ID. So in this time, this is my image collection. This image collection I need to import in my code editor. So how I can import? For importing that, simply copy the Earth Engine snippet copy. Okay, I copy it and then paste here. Simply paste. Okay, and then give a variable name. Suppose I put the variable name is that Landsat 8. You can use any variable name. There is no problem. Okay. So in this time, I simply copy the Earth Engine snippet or unique ID and paste in my code editor. Then give a variable name. You can use any variable name. There is no limitation, except we are not using the keyword. Okay. Suppose var keyword or other types of keyword is not make a variable. Okay. Without we can use any name. We can use any name. There is no limitation. Okay. So in this time, this image collection is imported in my code editor. Okay. And full image collection is stored in this variable. Okay. So now I want to check how many images are available for the whole world between the time period year of 2013 to 2023. How many images are available? So let's check how many images available. For that, use at the print function and call this variable name. Simply copy and paste here and use a size function. Okay. So mainly size function is determine how many images are available in this collection. Okay, it calculate that the size function. Okay, so now click to the run. In this time it computing how much image is available in this image collection. Okay, and this image collection is stored in variable Landsat 8. Okay, I simply call the Landsat 8 and then use the size function. So now this size function determine how many images are available. So now it continue computing about the result. We can get the large number of image collection. You can see it will be computing. Okay. So here you can say I find out the more than 1 million satellite images in here. Okay. So it's totally whole collection. Okay. For Landsat 8, whole image collection for Landsat 8 for the whole world between the time period year of 2013 to 2023. Okay. So now this large number of image collection, I need to filter. Okay. How I can filter? In this time, for filtering, it depends the three factors. Three factors. Okay, it's depend on the three factors. First factor is that we already discussed about that. First factor is your region. Okay, your region of interest. Which area you want to need? In this time, suppose I need the satellite image for the Dhaka city. Okay, here I already uploaded the Dhaka city boundary shape file. You can see I already uploaded in my asset. So I need the satellite image for this region of interest of Dhaka city. Okay, so just I simply import that. It will be imported. You can see it's the default variable is the table. Just I simply give a variable name, suppose ROI. You can use any name. In this time, this image collection I can got for the whole image collection for the whole world. But in this time, I don't need for the whole world. I need only for the Dhaka city. Okay. So for that, how I can filter it? So I give a variable name. You can take a variable name. You can use any name. I put the variable name, suppose filter region. Okay. Then I simply call the Landsat 8 because it is stored whole image collection. Okay. I paste in here and use a function is that filter bounds function. Okay. So mainly in this time, filter bounds function used for intersecting the whole image collection in my region of interest. Okay. So in this time, you can check the argument about that. You can say argument is the geometry. Okay. This argument is geometry. So now what is the geometry? Geometry mainly your boundary area. Okay. In this time, my boundary area will be Dhaka city. And Dhaka city is stored in ROI. Okay. Simply copy the ROI and paste here. Okay. So now let's check how many images are available in Dhaka city. Just simply use the print function and call the filter region. Simply copy and paste and use the size function. Click the run. In this time, I get how many images are available in the Dhaka city. I can get only 411 images are available in the Dhaka city. Okay. In this time, I also need to filter. Suppose from 411 images, I choose only for those images, which image will be not more than 1% cloud cover. Okay. I choose which image will be not more than 1% cloud cover. For that, I take another variable. Suppose I put the variable name is that filter. Suppose filter metadata. You can use any variable name. And then 411 images stored in variable filter region. Okay. So I simply copy that and paste here. From 411 images, I choose only for those images which image will be not more than 1% cloud cover. Okay, so I simply use a function filter metadata. Mainly this function filtering the image properties. If you want to check what is the value or what is the argument about the function, simply copy and paste in the docs tab. You can see the argument of this function is that name, operator, and value. Okay, so now what is the name? Name is the image properties name, and operator mainly is that symbol equals, less than, or less than equal, and value is the number. In this time I choose you can easily get all of those image properties name in here. You can see this is the image properties name. I choose the cloud cover less than 1%. So simply I copy the cloud cover. This is my image properties name. I copy and then I paste here name. Then operator is the less than, and set the value for 1. Okay. So now I want to check for my region of interest in Dhaka city, how many images are available which are less than 1% cloud cover. So use the same function, print, and call the filter metadata, copy that, and use the size function. Okay, because size is determine how many images is available. So let's check. I can got only for the 61 images is available for the Dhaka city which are less than 1% cloud cover. Okay, suppose I want to need 5% cloud cover, use here the 5. Then this number also increasing. So I simply 5 and click to the run. You can see now how many images I got. I can get 107 images which are less than 5% cloud cover. So I need the less cloud cover. I put here the one less than 1% cloud cover. So here I find out total 61 images. Okay, and this 61 images, what is the time duration? This time duration is that year of 2013 to 2023. Okay, but I don't need for the whole time period. I need only for this image year of 2020. Suppose I need the image only for year of 2020 or any specific time period, rainy season, summer season, or any time period. For that, I need to filter date function. So I take the another variable. Suppose I put the variable name is that filter date, and from 61, okay, from 61 images, I choose only for those images which images are available in year of 2020. For that, I simply copy this variable name and paste here, and then give a variable name filter date. Mainly this filter date function filtering the specific time period. Okay, here I put start date and end date. So I simply put here this, suppose year of 2020 1st January, and also put here that year of 2020 suppose December 31. Okay, so in this time period I can get only for the 1 year. Okay, year of 2020 1st January from December. So now I want to check how many images are available between this time period, year of 2020. So put here the print and then simply copy the filter date and paste here and use here the size function. And now let's check how many images available. I got total 5 images. Okay, so you can see I can get only for the 5 images. Okay, and these 5 images is available in my Dhaka city region, and this 5 images is the less than 1% cloud cover, and this 5 images is the available for year of 2020. Okay, so first of all, you can see here I find out the large number of image collection for the whole world. Okay, when I applying this only for the Dhaka city, I got 411 images. Okay, from 411 images, I choose only for those images which image is the less than 1% cloud cover. I find out 61 images, and from 61 images, I choose only for those images which image is the available for year of 2020. I find out finally 5 images. Okay, so this is the process for filtering. So here I can get the large number of image collection for the whole world for the full time period. This I filter according to the, first of all, my specific region. So it also called the IR. Okay, and it also called, we also call about that how, and it also called about the when. Okay, so mainly when you want to filter the image collection, it can be Landsat or Sentinel. So just you can ask the question, where the place you need the satellite images, Dhaka city. So put at the your shapefile variable name. Then how you can filter that? I want to filter less than 1% cloud cover. Then when is the specific time period when you need this satellite image? I need the image for year of 2020. Okay, so mainly filtering process is that where, how, and when. When you can fill up all of those things, then it will be filtering. Okay, so in this time you can say I find out the large number of image collection, and finally I filtered that I can got only for the 5 images. And what is the factor? Where, how, and when. This is the 3 factor for filtering. Okay, so anyone any question about the filtering, you can ask me, or any doubt. Yeah, any question? Okay, okay, so I'll okay, I also try to show the another region after doing that, it also better. Okay, so okay, so just simply, okay, in this time I can get the result for the 5 images for the Dhaka city finally. So now I want to check what is the acquisition time period of this satellite images. Okay, because these 5 satellite images is not captured at the same time of the year. Okay, is not captured at the same time. So for that I need to check about the acquisition time period. For that, what can I do? Just simply use the print function and call the filter date. It is my variable name because 5 images stored at the filter date. I paste here and then click to the run. In this time I can get the all of this information. You can see about the acquisition time period. Click on here, I can click on the feature. So first of all, you can see here I can get total 5 images. Okay, and all of those images total 19 bands. Okay, and first image you can see 0 refers to the first image is the year of 2020, 11th February, 26 January, 11th February, 30 March, 27 December. Okay, so in this time, if you want, you can work only for the single time, single date image. Suppose I want to work only for the single date image. Suppose I want to work with this image. Which image acquisition time is that year of 2020, 11th February. I want to work with this image. So how I can do that? For single date image, how I can use? So for that, simply copy this ID. Simply copy this ID. Okay. So this is the process when you want to work for the single date image. Suppose you want to use the single date image for NDVI or land use land cover classification or anything you can do. For single date, simply copy the ID. And after that, so for that, I simply take a variable. Suppose I put the variable name is that image, and then ee.image, this function I use, and paste the ID, which I copy in here. Okay, just paste. Okay, so now display the image. So for that, I add a layer. So use add the map.add layer. I want to display the image, which I add in here. It is stored in the image variable. Simply copy and just paste in here. Okay. Now click to the run. You can see one layer will be added in here, but I did not focus. For focusing, how I can do? Just use the another function, map.center object. Okay. So map.center object, and call the object name is the suppose image. Okay. And then click to the run. So now it focus on the center of this image. Okay, you can say I can get the image. I can get the image as a tiles in here. Okay, I can get the image. And what is the acquisition time about the image? Year of 2020, sorry, year of 2020, 11th February. Okay, this is the acquisition time of these images. So now I want to display the, suppose, different types of band combination on these tiles. So basically it is a tiles. Okay, so and it also cover my region of Dhaka city. Okay, so because you can see this Dhaka city in this region, and it successfully cover, you can see cover it, it successfully covered. If you want to check it, suppose I want to add here the Dhaka city boundary shape file, so use at the map.add layer and call the shapefile variable name RY and click to the run. So then we can easily get the Dhaka city boundary layer also, and also get the tiles. So you can see here, this is my Dhaka city boundary. Okay, and this is my tiles. So this tiles is fully covered. This tile is fully cover my region of interest. So that's why I can easily use the tiles for my region of interest and work with the different types of remote sensing. Okay, so this is my area of interest. You can see this is my Dhaka city boundary. Okay, and this tiles is cover my region. So in this time, I want to show the different types of band combination. So how I can add the band combination? So for adding the band combination, just simply click on here, and here you can get all of those band. You can see SRB1, all of those band I can get in here. So in this time, I add here the red band, then green band, and also blue band, and custom 98% for better reflectance, and then apply it. So now I can say I can get this true color composite. Okay, so it's called the true color composite. I can get the true color composite satellite images for the whole tiles. Okay, so any band combination you can use in here. Suppose I want to put here the near infrared band, then a red band, and then put here the, suppose, blue band, and 98% apply. So now I can get the another types of band combination. It's called the false color band combination. Okay, so mainly spectral indices, different types of band combination we are using for extracting the different types of information from the satellite images. So I will try to discuss a lot of things about that when I talk about the land use land cover classification using the different types of spectral indices, how you can easily identify different types of feature. So then I hope you can easily understand about that. So in this time, suppose I simply use the true color composite or natural color, red, green, and blue, and apply it. So now I can get the natural color. And now this color I need to import. Okay, so how I can import? Simply click on the import. You can see when I click on the import, a new line of code will be added in here. Okay, click to the import, new line of code will be added in here. Simply copy that, and then paste it after the object name. So this is my image. I want to set this band combination, this image. So that's why I simply copy the variable name and paste here. Okay, this variable name where I can get, when I apply, click on the import, it's added a new line of code. Okay, I simply copy the variable name and paste after the image variable. I paste here. So now this color is set. You can see when I click to the run. So now I can get the true color images. It will be set. Now you can see, okay, now it will be set. Okay, you can see in this time I can get the true color composite because I set the color in here. Okay, so in this time I don't need for the whole tiles. I need only for those, I need the tiles only for the Dhaka city boundary. Okay, so for this I need the satellite image for the Dhaka city boundary. For that I need to use a function, this function called the clip function. Okay, so just I simply use a function in here, clip, and clip with my geometry. In this time my geometry is that ROI. You can see Dhaka city is ROI. Okay, just simply use that ROI and click to the run. In this time I can got this image only for the Dhaka city. Okay, it working. Okay, So now I can see in this time I can get this image collection only for the Dhaka city region. Okay. So when I use the clip function, it clipping with my geometry. Geometry is the Dhaka city boundary. So now I can get this image for the Dhaka city boundary. So now I can easily apply the different types of remote sensing analysis such as land use, land cover, or NDVI, NDWI, any types of analysis I can easily do in this time in here. So, and this image is only for the single time period image. What is the acquisition time? Year of 2020, 11 February. Okay. Sometime you also need to use the median composite or mosaic composite. Okay. For that, how I can do that. Okay. So in this time it process for the single date image. How we can easily work about that. But if you want, you can also work for the median composite. Suppose here I can get total 5 images. Okay. I want to create the composite using the median pixel value of all images and create the median composite. Okay. Using the total 5 images, I get the median pixel value or middle level pixel value and make a composite. So how I can do that? For that, I take a variable. Suppose I put the variable name is that median image. You can use any name, no problem. And this 5 image is stored in variable filter date. Simply copy and paste and use here the median function. In this time, this median function mainly take the middle pixel value from all of those 5 images and create this composite. Okay. I just put here the clip function because I need only for the study area of Dhaka city. So now display it. And click to the run. Okay. So now you can see it will be added the median composite. In this time, this composite is created from total 5 images, middle pixel value. So in this time, I also need to add here the band combination and also set the visualization. So how I can do that? Just simply click on here and then set the band combination such as I set the suppose red band, then green band, and also blue band, and custom 98% for stress the reflectance, and then apply it. So now I can get the true color composite, and this visualization parameter I need to import. So just simply click on the import. It will be imported. You can see imported in here. Just simply copy this variable name and paste after the object name. So in this time my object is that median image. Just I paste in here. After that, paste in here. So now it's set it with my code. Okay. So in this time I can get the median composite from total 5 images, middle pixel value, create this composite. Okay. It's not a single image. It created total 5 images median pixel value and make a one composite. Okay. But when you want to work with the single date image, so just simply copy the ID and follow this approach. Then we can get the single date image. And in this time, it called the median composite image. Okay. So this is the process for showing that visualize, filtering and visualize the satellite images in Google Earth Engine platform. So in this time, here you can see, I use lot of code in here. Suppose when I use the filter bounds function, I take a new variable. When I use the filter metadata function, I also take a new variable. When I use the filter date function, I also take the new variable. But if you want, you can take only for the one variable, and under this variable, you can put all of those functions. Okay. So then it will be reduce the line of your code and you can write the code easily. The first time I do it because for your understanding how it will be filtered. Okay. One by one, I write the code. But proper way is that I take only for the one variable, and under this variable, I put all of those functions. So let's go how I can do that. So just I simply commenting all of those lines. When I comment that, it will be not running, okay, not executed. So just I simply select all of those things and then press Ctrl//. Then it will be comment. In this time, it will not work or not executed. So in this time, I just take only for the one variable, and under this variable, I put all of those functions. So let's go. Take a variable, suppose image. and call the full image collection Landsat 8 because it stored the full image collection, total more than 1 million images. I simply paste in here and use the function. First of all, filter bounds function. Mainly this function give you the answer where the region. In this time, this region is the Dhaka city. So put here the ROI. Okay, because Dhaka city stored the ROI in variable. After that, I can simply put here the how. How I filtered that. For that, I need to use here the filter metadata function. Filter metadata function. In this time, I need only for this image, which image will be not more than 1% cloud cover. So just put here the cloud cover. So just put here the cloud cover, and put here the operator is that less than, and set the value. Suppose 1. Okay. And then when you need this image, just put here the filter date for the when. Just put here the time period of 2020. 1st January from year of 2020, December 31. Okay, this is the filtering approach. So first of all, it gives the answer about the where the region, and give the answer how we can filter, and give the answer when. Okay, so when you put the where, how, when, it will be done for filtering. After filtering, if you want to need for the single date image, suppose you need the single date image, so how we can do? Just you can simply print that. Just simply print, and then simply copy the image variable name and paste here. Click to the run. Okay, so in this time I can get all of this image acquisition time. After filtering, you can see I can get all of this total 5 images with their specific time. When you want to order single date image, simply copy the ID. Okay, simply copy the ID and follow this step which I already show you. Okay, so in this time I create the median composite. I not work for the single date image, just use here the median. Okay, and when I use the median, then I also need to clip with my shapefile, is that ROI. Okay, and then finally I want to show the result. Use here map dot add layer function and call the image and click to the run. In this time you can see I take only for the one variable. In this variable I put all of those functions: filter bounds, filter metadata, filter date, and median, and click. And finally I display the result. So now I simply copy the variable name, I already set it, and paste after the object name. So now it gets the visualization about the true color composite. Okay, so it's working. Okay, so now I can get this image look like that. Okay, so now anyone any question about the full code, you can ask me. Anyone any question about that?
Hi, I have a question.
Yeah, please.
My doubt is that can you please explain me, I mean, what is actually a median composite image, basically?
Okay, so basically median is a statistical function. So median take the middle pixel value from total 5 images. Suppose in this time I can get total 5 images. Okay, so it make the distribution about the total 5 images, and every single images get the middle pixel value. Suppose in this time from 1, 5, 10. In this time it takes the 5 from the one image. Also, suppose I get the another pixel value, suppose 10, 20, and 40. It take the 20 and make this composite. Okay, just take the middle pixel value, all of those images. Basically in this time what we can get in this image, so all time I can get the pixel value. Okay, different pixel value, and create these full images. Okay, in the median, when I use the median function, it take only for the middle pixel value of the images. So when I use the middle pixel value, total 5 images, then it calculated the every single images middle pixel value and make this composite. Okay, so just take the middle pixel value and
That
make the
mean,
composite. Yeah, yeah,
yeah,
please.
like does that mean when it takes the middle pixel value of five images,
Yeah,
then it do the this median of these five values and finally show us the
yeah,
picture,
yeah,
actual picture? Is it like that?
yes, yeah. It's yeah,
Okay, and one more thing, like these five images which you say, these five images may be of different dates, right?
yeah.
So they are actually doing the median of all the five different dates values. Is it that way?
Yeah. So all of those different value create this composite.
So in that case, if someone asks me, I mean, what is the actual acquisition date of your final product, then what should I say? I
You
mean,
can
like,
say about that this
is
final product is created from total 5 images median pixel value. Okay, in this time there is the no
means
acquisition
five.
time image for these images because it created an whole time period. You can also say about this year of 2020, this full time year, how many images available, all of those images I use for and take the median pixel value and create
So
this
so
composite.
in that case, can I say that this image is of year 2020?
Yeah,
Rather
yes,
than mentioning the date, we can say that it is of the year 2020. It considers
yes,
all the available images.
yeah, yes, yeah,
Okay,
yes,
okay, thank you.
because in this time period we get all of those images and make the median composite. Okay, okay,
Thank you.
okay, okay. Okay. And then this is the process for the single data image. How can I get the single data image? Okay. So now I talk about that export. How I can easily export these satellite images from the Google Earth Engine platform and also work with other software such as ArcMap or QGIS software or RStudio. How we can easily work with that for exporting. Okay. And before exporting, I try to discuss about the another data set for Modis NDVI data set because exporting is the same approach. When you want to export anything as the image, it can be in this time it showing the Landsat image. Same approach for the Sentinel, same approach for the Modis. All of those things will be same. Okay. So in this time I talk about the Modis one data set, then move to again in here and show you that how we can easily export it. Okay. So in this time, this is the process I just show you that how we can easily filtering and displaying the satellite images and use the different types of band combination from here. Okay. So in this time, I simply go to my slide and exporting. I try to show you after some time for exporting how we can easily export about this satellite image. So now I talk about that how we can easily import the data from the Earth Engine data set. Suppose you want to work with the Modis, then you have to import the Modis data. When you want to work with the Landsat, you need to import the Landsat data. I already show you about the Landsat data, how we can easily import. Okay. So then we talk about that how to filter this data. Okay. Then how to reduce this image collection and then how to clip on your shape file and then how to display the result on the map and how to reproject it the scale pixel value. Okay, sometimes we can get the some unpredicted scale value. For that we need to also scaling about the pixel value for getting the right scale value. Okay, so let's go. I talk about that, then talk about this. Okay, just I simply open a new code editor. So in this time, I simply go to the data set, data catalog. I want to work with the Modis. So here we find out lot of Modis product. You can see there are a lot of Modis product, and all of those Modis products. When you want to work, just apply the same approach. Okay. Suppose I want to show the data set for LST. You can also apply the same approach for Modis NDVI or Modis leap area index. Okay, same approach all time. Okay, so in this time, suppose I want to work with the data set for trap vegetation indices 16-day global 250-meter resolution. This data set I use and then show you that you can easily apply the same approach other data set which are available in here for the evapotranspiration data set Also, you can see the gross primary productivity data set. So you can easily apply the same approach. Okay, so let's go. I simply open the data set, click on here, and I can get all of this information about the data set. Mainly, this data set is that available, that time is that you can see from year of 2000 to 2023. This is the data set provider. Okay, and this is the unique ID of this data set. All of those data set has a unique ID. Okay, we already show the unique ID about the Landsat image. You can see Landsat surface reflectance select image is unique ID. In this time, we also get the another unique ID about that MODIS in vegetation indices, this unique ID. So all of those data set, we got the unique ID. Okay, so in this time, I want to import the data set in my code editor. So how I can import? Just simply copy and then paste here. After that, give a variable name. Suppose you can use any name. Suppose I put the MODIS. I put the MODIS. Okay. So now I import this image collection is successfully imported in my code editor, and it is stored in this variable. Okay. So this is the one way for importing data set. Or if you want, you can simply search here. Suppose MODIS NDVI. Just simply search the MODIS NDVI. So now it suggested all of those MODIS NDVI data set. Okay, you can see. So I want to use the data set. Okay, simply click on here. Here I can get all of the same information. Basically, this is the catalog page, and this is the small information about the data set. But this information is the same. Okay, all of those things will be same. You can see also the unique ID about the data set. Same unique ID. Okay, also you can get all of those things. Basically, this data set provide you the two product. One is that NDVI, normalized difference vegetation index, and EVI, enhanced vegetation index. Okay, so also you can get the resolution is the data set 250 meter resolution, and this data set is the global data set. We can easily get the data set for any region. Okay, and this data set is that it already marks the unnecessary pixel value such as water, cloud, heavy aerosol, cloud shadow. All of those things already masked. So that's why when you are using this data set, we can get the very clear NDVI map using the MODIS. Okay. Okay. So anyone any question? Yeah, please. Yeah.
Yeah, my question. Okay, yeah, please go ahead. I will ask later.
Yeah, so my question was about what's the difference between these MODIS like 16, MODIS 15? Yeah, what's the difference?
Its difference is that pixel area. Okay, suppose you can see here in this time I can get the MODIS is that 250 meter resolution. Mainly it is the pixel area. Sometimes we are also work for the Landsat. You can see we can get the 30 meter. So it is that resolution is that 250 meter. It is the pixel area. Suppose 250 meter square. It take the information from 250 meter square. This range, it take the information. When I use the 30 meter for Landsat, then I can get the high resolution than MODIS because it take the information only for the 30 meter. Okay, so this pixel area is also low for that Landsat. For the Landsat, this pixel area is low. That's why this resolution is high. Okay, and in the meantime, this resolution is pixel area is high. You can see 250 meter means that this pixel area is high. It means that this resolution is low. Okay, so it extracts the information from 250 meter area, square meter area. Okay, but when you are using the Landsat, it extracts the information only for the 30 meter square area. Okay, because it is the pixel area. When pixel area is low, then resolution is high, and when the pixel area is long, then resolution will be low. Okay. Okay, I hope you can understand about the pixel area and resolution.
Yeah, okay. Understand. Yeah, okay. Can you, if possible, can you use MODIS 16?
MODIS?
Can you use in this lecture? Yeah, MODIS 16.
Okay, so it is the MODIS product, any product or data set about that. Okay,
Okay.
I also show you about that Landsat image also, how we can easily perform the Landsat. Okay, so all of those things I will try to discuss one by one. So I hope we can easily learn about that. For the MODIS, Landsat,
I have a
Sentinel.
question.
Yeah. Yes, please.
My question was kind of similar question only. My question is that like if I want to make a map of NDVI of resolution 10 meter, high resolution.
Yeah.
Okay, so in that case, I mean, how we can make it? I mean, 10 meter is not available basically. I mean, as you said, the Landsat 30 meter is available. Let's say if I want to make a 10 meter NDVI map. So in that case, what will be my approach?
Okay, so first of all, you have to find out the image collection. Which image collection is not available in a 10 meter. So for that, some resolution, suppose you can see, I also show you the another data set. This data set is mainly high resolution. It's called the NAVE data set. But this NAVE data set is only available for United States. Okay, so it is only for the 0.6 meter.
My question is that
Yeah.
my no,
Yes,
my
please.
question is that for India, let's say for India, the
Yeah.
highest resolution available is 30 meter, you said, right?
No,
So
highest
from
resolution we
30
can get
meter,
from the
we can do
Sentinel imagery,
reclassification and go to
10
10
meter
meter.
to 12 meter.
So from that image, can we create a map of NDVA of 10 meter?
Yeah, we can create for the Sentinel imagery.
So what is the highest resolution available?
10 meter to 12 meter, this range. Here
10
you can
to 12
see,
meter for
yeah,
India.
yes.
Okay.
So you can check the image
Okay.
collection for
Okay. So,
Sentinel. Yeah,
yeah, please, can you please show it once? Yeah, that would be very helpful.
yeah, you can see the Sentinel multi-spectral instrument. Suppose I use at the top of atmospheric, or you can see the resolution about that image is that you can simply click on the bands. Here I can get the 10 meter, you can see. Okay, 10 meters. So this is the highest resolution freely. Okay, we can easily use the highest resolution freely up to 10 meter. But if you want to use the more highest resolution such as 0.5 centimeter or this type, then you have to buy the satellite images and work with that. Okay, we can get the
No,
highest is
but
the
here
10
you
meter.
said it is uh, highest is 10 meter for a particular band, not for like all the bands.
But
But when
when you
we
want to
do
work for the
NDVA,
NDVI is only work for the red
okay,
and near infrared. You can see red and near infrared is the 10 meter. Okay.
okay, got it.
Yeah,
Got it.
but you can check the
Thank you.
formula about that. Red and near infrared is a 10 meters. So that's why when I use here the 10 meter resolution or pixel area, then I definitely I can get the NDVI map 10 meter.
Okay, understood. Fine. Thank you.
Okay, okay, thank you. Okay, so now let's check our class. I also show you all of those step one by one. Okay, so there's a don't worry for that. Okay, so I go to the step by step. So in this time I talk about the MODIS. Okay, which resolution is the 250 meter resolution. So we can get the two product. So MODIS is also called the ready-made data set. Okay, so why it's called the ready-made data set? Because this data set already create the NDVI, EVI, this type of band already created. So it's a one kind of ready-made data set. This data set, from this data set, I can easily get the NDVI map without apply any types of equation, such as near minus rate divided by near plus rate. So this type of equation, I don't need to use in here because it's a ready-made data set. Here I can get the ready-made data set. I can easily make the map. Okay, so let's go how I can do that. So here I import the image collection. Okay, and this image collection has a two band. You can see NDVI and EVI. I want to work with the NDVI. How I can do? Simply copy the band name and use the function is that select function. Okay, select the NDVI band. Okay, so basically this image collection has a two band, but I want to work with the NDVI. So that's why I use the select function and select my requirement band NDVI. Okay, so now you can see this image collection. I can access the data from year of 2000 to 2023, this time period. But I need only for the year of 2020 or 2022. For that, I can simply use a function filter date function and put here the specific time period. So filter date function and put here the start date, suppose year of 2020, 1st January from year of 2020. You can use any time period. I randomly put the example about that. December 31. Okay. So now let's check how many images is available between this time period for NDVI for the whole world. Okay, let's check. So I simply use the print function and call the modis and use the size function and then click to the run. So now it displays the result. How many images? We can get the 23 images. Okay. So 23 images I get in here. And you can see here, this image, when I suppose I multiply 23 into 16, then it almost covered the 1 year. Okay, 365. It's almost covered the 1 year. 23 images I can get for the 1 year. When I multiply with the 16, then it completed the 1 year. 365 or 368 complete the 1 year. So in this time, you can see this data set is also called the 16-day. Okay, 16-day means that every 16 days time interval I can get the data. Suppose I can get the data 1st January, then second data I can got in that after interval 16 day or 17 January. Okay, so in this data provide you every 16-day time interval. We can get the data for NDVI. So in this, because that's why it's called the 16-day. Some data set you can say about the daily data set or 8-day data set, okay, or 32-day data set. It means that we can get the time interval. How much time interval I can get the information or get the data. So it called the 16-day. It means that every 16 days interval I can got the information from here. Okay, so now here I can get the 23. If you want to check the acquisition time, simply use the print and call the modis, simply copy. In this time I can get all of those acquisition time. And acquisition time interval is that 16 day. You can check the time from here. For the 1 year, we can get 23 images. You can see first image, 1st January, 17th January, 2nd February, 18th February. So all of those images we can get about that 16-day interval. Okay. So in this time here I can get 23 images. Okay. These 23 images I need to reduce for displaying the result. Okay. So mainly in Google Earth Engine platform, reduce is an statistical function. We can reduce in different way. Suppose you want to extract the maximum NDVI value, you want to extract the minimum NDVI value, you want to extract the average NDVI value from 23 images. Okay. So in this time, I need to apply the reduce. So in this time, I want to apply the reduce for getting the average result. From 23 images, I want to extract the average NDVI result. So for that, I simply use suppose take a variable average, suppose average NDVI, and then I simply call my modis, this variable, because this variable is stored 23 images. Okay, I simply call. In this time, these 23 images I need to reduce. So use the reduce. And then how I can reduce? Then I need to define in here. I need to reduce using the average pixel value. E dot reducer dot min. Okay. So now what happened? In this time, from 23 images, it calculated the average pixel value. Okay. From 20 modis is stored 23 images. Okay. This 23 images I want to reduce. How I can reduce? I want to reduce using the min function. So in this time, it calculated from the 23 images average pixel value and make this map. So let's check about the map. So use the map dot add layer. and then call the average NDVI. I display the result. In this time, this result showing for the global whole world. In this time, I can get the NDVI map for the whole world year of 2020. Okay. In this time, we can see it's showing this type of map. It's not showing the colorful because I did not add any visualization. Okay. So in this time, I can simply put here. Suppose I make the visualization. So for that, you can see they already provide some demo code in here. So I simply use the demo code. Simply copy the color code. Simply copy and paste here. In this time, they are make a dictionary. You can see using the curly bracket. They are make a dictionary. Mean pixel value of NDVI start from the 0 and maximum pixel value up to 8,000. And they also use the different types of color plated in here. I simply copy that and paste after the object name. So I paste in here. So now it's set with my average NDVI visualization code. Click on here. In this time, I can easily find out where is the for the whole world NDVI map year of 2020. So now I can see display the whole world NDVI map year of 2020. Okay, we can get the map for the whole world year of 2020. But in this time, I don't need for the whole world. I need only for the specific country or a specific boundary, anything. So for that, how I can do? Just I simply take a boundary shapefile from USDOS dataset. Basically, it provides the country boundary shapefile. So just I simply use here the USDOS dataset and I import that dataset. And this dataset I filter for the specific country. So for that, use that take a variable. Suppose I put the variable name is the country, and then I simply call the table because this table is stored the all of those country boundary shapefile. This table I need to filter. How I can filter? Earth engine dot filter dot equal. Now arise the question: what's equal what? Put here the country NA and put here the country name. Suppose I put the country name. Suppose Bangladesh. Okay. So in this time, Bangladesh country boundary shapefile is stored in this variable. Okay. So just I simply clip. Okay. Just I simply use the function. So just I simply put here the clip function. Use here the clip with the geometry. Geometry is the Bangladesh. Okay. But Bangladesh shapefile is stored in the variable country. Just simply copy the country and click on here. And then click to the run. So now it display the result only for the Bangladesh boundary. So here you can see it will be display, but not focus the Bangladesh. So I need to use here the map.center object function for focusing. Just use here map.center object is that country. Suppose zoom level is that suppose 8 and click to the run. So now it focuses the country boundary shapefile of Bangladesh. I think something wrong in here. Okay, let me check. I run the code again. Okay, average anyway. Okay, just I simply click with my country COUN. Yeah, right. Okay, let me check. Okay, so it will be appear for the whole world. Okay, but in this time I need only for the study area of country. I check about this. It is the okay country NA. I put the wrong spelling in here. Okay. So now it okay country NA Bangladesh. Now it will be stored at the Bangladesh boundary shape file, and then I simply use the clip function, clip with, simply copy that variable name and paste here. So now I can get the result only for the Bangladesh boundary. Okay, I hope okay it will be work. You can see now I can get the ND map Bangladesh. Suppose in this time I also need to center focus of the Bangladesh. So for that use here the just put here the map dot center object and put here the object is that country, zoom level suppose 10 and click to run. So now it focus the center of the Bangladesh and also display the map of NDVI. Suppose in this time any country boundary, you can simply set the country boundary. Suppose I put the country boundary, suppose Saudi Arabia and click to run. In this time it display the result about the Saudi Arabia NDVI map year of 2020. So any region, just simply put the country name. Okay, so this is the crop plant. You can easily identify from here. You can see. Okay, suppose I need this map for any country boundary. Suppose I put this Australia. Click the run. So now I can get the NDVI map of Australia. Then it is Australia NDVI map we can get in here. Any country boundary, simply paste. Suppose I put this South Africa. Click the run. So now I can get the result for the South Africa NDVI map year of 2020. And after that, we can easily export this map from here. Okay, and then work with the ArcMap software or QGIS software for making the research paper map. Okay, I will show you all of the steps one by one. You can see the map for the South Africa NDVI map in here. Okay, so we can easily find out the dense vegetation. There is no vegetation. Okay, so in this time, this map is created, but this map has a problem. This problem is that scaling. In this time, if you want to check the value, suppose click on the Explorer tab and click on this any click on the map, you can see what the pixel value I can got. I can got the pixel value is that 7,213. Okay, click on here, I can get the value of 448. In this time, it has some problem. This problem is that we need to reproject this scale value because you can check the NDVI index. So NDVI range, basically NDVI range will be -1 to +1. Okay, -1 to +1. So NDVI range. So you can check the NDVI range all time, +1 to -1. Okay, this value. And in this time, this I can get the pixel value look like that. It's not maintain the sequence of the scaling about the NDVI -1 to +1. Okay, so that's why I need to reproject this scale factor for get the proper NDVI map with scaling. Okay, so that I can get the result about the NDVI -1 to +1. Okay, so let's go talk about that, how we can easily scaling about that. For scaling, first of all, we check about the data set. You can see this is the data sheet information, data catalog. So in this time, they already provide the scale. You can see this is the scale. Okay, for NDVI, what is the scale? 0.001. So this is the scale, and EVI same scale. In this time, I need to apply this scale value and reproject my map for getting the result -1 to +1, this range. So in this time, It's very easy. Just I need to multiply this value with all of images, total 23 images. Okay, I need to just multiply, then it will be reprojected. Okay, I think some question. Yeah, please.
Yeah, my question is that can you explain me what is the physical difference between NDVI and EVI?
Okay, okay. So basically, NDVI and EVI, it is similar to normalized difference vegetation index, but it can be used to quantify vegetation greenness. Okay, so NDVI can be used for quantify vegetation index, and EVI it mainly correct for some atmospheric condition, and also canopy background noise is more sensitive in areas with dense vegetation. Okay, so EVI is the correct or the correction some atmospheric condition already done in the EVI, and also it also canopy background is the noise is more sensitive in areas with the dense vegetation. When you want to identify, then we have to use the EVI or enhanced vegetation index. So mainly it's need when you want to work with for the forest region, then we are also using the EVI, and NDVI is mainly it's used for quantify vegetation greenness, and EVI is the sensitive in areas with the dense vegetation region. Okay, basically this is a
I mean,
similar
like
index.
for agricultural land, if I work on agricultural land, so in
Yeah,
that case, I mean, which index would be appropriate, NDVI or EVI?
NDVI. Okay, because we need to
Why so?
identify the quantify of the vegetation greenness.
I mean, why not EVI?
EVI is mainly work for the dense vegetation. For that, you want when you want to work for the forest region or other region, which we can get the more vegetation. Okay, forest region, then it also better for the EVI using that, because EVI it is a canopy background noise is more sensitive areas with the dense vegetation. When you want to work, then EVI is better, and mainly when you want to work for the normal land cover for that agricultural land, it's not more dense vegetation about for the agricultural land or other things, so that's why then NDVI is better for that. Okay,
Can we produce EVI maps from Sentinel 10-meter data?
yeah, of course, yeah, I will show you all of the things. Okay, so AVI is possible for the Landsat Sentinel, we can easily do that. For that there is no problem. Okay, for EVI or NDVI.
Will that be a part of the course? I mean, to generate the EVA maps?
I don't understand.
My question is that will that be a part of the course to generate the EVA maps from
Yeah,
Sentinel
yeah,
data?
yeah, of course. Okay, so not only for the EVI, I will teach you any approach, all of those approach. Using this approach, you can create any types of calculate any types of indices. Okay, so EVI, VCI, TCI, which you need. Okay, I will show you all of those technique, all of those things, so that's why you can easily calculate any types of indices. Okay, any types of indices. Okay, just follow the equation, put the equation, and you can calculate. Okay, anything we can do for that. Okay, there is no problem. I will cover all of those things step by step, inshallah. Okay,
Okay,
so
thank you.
okay, so now here I can get this type of map. I need to reproject it. How I can reproject that? Just simply multiply with my scale factor. So in this time my scale factor is the 0.001. Okay, this scale factor I need to multiply with all of those images. Okay, with all of those images means that total 23 images. Okay, for 1 year, total 23 images. I need to multiply with a scale factor 0.0001. Okay, then it will be reprojected. So now how I can do that? Okay, so for that I can simply help of function. Okay, using the function I can easily multiply with my scale factor 0.001 with all of those images, mainly 23 images. Okay, so let's go, we try to discuss about that. For doing that,